Hello my dear students, good afternoon, welcome back for the next lecture. In the previous lecture, we have done a topic, line integral of the electric field lines, or you can say line integral of electric field. In that we have proved that the electric field is conservative. Also we have done and we have derived the work done in moving a test charge from one point to another point in an electric field of a charge Q. So this was the outcome. In the previous lecture I have derived this thing. See, this is derived in the previous lecture. What is this? Work done in moving a test charge from a point A to point B in the electric field of a charge Q, and it is work done per unit test charge, which is equals to the negative of the line integral of electric field, and it is equals to this thing, where what is RB? RB is the position vector of the point B, which is the final point, and RA is the position vector of the A, that is the initial point. And we have proved earlier in the previous lecture, if it is closed, the answer is 0. It means the electric field is conservative. For the closed path, the work done is 0, and it doesn't depend upon the work done, doesn't depend upon the nature of the path followed. It only depends upon the initial and the final point. So we have derived this expression, which is very important expression, and it is the basic concept behind the electrostatic potential. Now today I will explain you electrostatic potential. Now, electrostatic potential, before explaining electrostatic potential at a point, I will explain electrostatic potential difference between 2 points in the electric field. So for example, this is a charge. For example, this is charge Q, which is called a source charge. तो आपको पता है इसके आसपास क्या होती है? इलेक्ट्रिक फील्ड होती है. तो for example, this is a straight line. So for comfortable derivation, I am taking 2 points. For example, this is point B, and say very far away from it, I am taking a point, say A. Here it is. The electrostatic potential difference between 2 points in the electric field. So, ये किसकी electric field है? ये इस चार्ज की इलेक्ट्रिक फील्ड है, और ये 2 पॉइंट्स इस इलेक्ट्रिक फील्ड में है. For simplicity, I have taken these 2 points on the same straight line. Otherwise, you can take anywhere. ये मैंने पिछले लेक्चर में बताया, you can take these 2 points anywhere in the electric field of this Q. But for example, this is point A, this is point B. B वाला पॉइंट इसके पास है और A वाला इससे थोड़ा दूर. So what is the electric potential difference between these 2 points? How it is defined? The electric potential difference between any 2 points in an electric field is defined as the work done in moving a unit positive test charge from one point to the other against, see the word against the electrostatic force of the field without acceleration. See, and the important point, ये मैंने पिछले लेक्चर में बताया आपको, we are moving against the electrostatic force and it is without acceleration and irrespective of the path followed. These 3 points are very important. We have to move a test charge from one point to another point. There is no problem, we have to move it, but it should be moved against the electrostatic force, because work is always done by some external agency and it is always done when we are moving against something. So we are moving against the electrostatic force without acceleration and irrespective of the path followed. तो आप A से B आप आना चाहते हैं, I am taking a straight path, otherwise you can move anywhere. It is irrespective of the path followed. कैसे भी चार्ज को लेके जा सकते हैं, और against जाना है, दूसरा without acceleration जाना है. तो for example मैं एक चार्ज को यहाँ से यहाँ लेके आता हूँ. आपको मालूम है, अगर मैं यहाँ से यहाँ चार्ज को लाना चाहता हूँ, for example एक पॉइंट P में, फिर से एक्सप्लेन करूँ, ये पॉइंट P पे चार्ज पहुंच चुका है, कौन सा चार्ज है? Q नॉट है. तो इस पे फोर्स एक्सर्ट करेगा, ये चार्ज किस तरफ एक्सर्ट करेगा? इस साइड. This is the force exerted by this charge on the test charge, जिसको हम यहां से यहां लेके आ रहे हैं. और ये फोर्स का मैग्नीट्यूड कितना होता है मैंने पहले भी बताया, इट्स क्यू नॉट ई. तो हमें उस फोर्स को ओवरकम करना है, जिसके लिए हमें एक्सटर्नल फोर्स लगानी है. और एक्सटर्नल फोर्स किस तरफ लगाएंगे? इस तरफ. ये जो एक्सटर्नल फोर्स होगी ये इसी के ऑपोजिट होगी और मैग्नीट्यूड इसके बराबर ही होगा. ये हमें बिल्कुल ऑपोजिट होगी. अगर ये फोर्स इसके ऑपोजिट है तो व्हाट इज द नेट फोर्स ऑन दिस charge at which is at point P? It is 0. If the net force acting on the charge is 0, it means there is no acceleration. So see here, we have applied the force against and there is no acceleration. And the path can be anywhere. In the previous lecture I have taken an arbitrary path, but for simplicity here I am taking a straight path. तो हम यहाँ से P से इस तरफ जा रहे हैं, for example यहाँ आ रहे हैं. So we have derived the whole thing. That derivation proves true here also. That was the master derivation जिसमें हमने arbitrary point लिए थे, arbitrary path पे लिया था. This is the, you can say, limitation of that कि हम यहाँ पे straight path, हम straight भी ले सकते हैं, कैसे भी ले सकते हैं. So this is the definition of electric potential difference between 2 points. It is defined as the amount of work done in moving a unit positive test charge from one point to another point against the electrostatic force without acceleration and irrespective of the path followed. These 3 lines should be there, and this is the derivation. If someone says derive the whole derivation, so you can derive all these things, and we will move further. So let's move further. This was the derivation which we have derived earlier. Let's move further. Click this, open it. What do you get? Q upon 4 pi epsilon naught RB minus Q upon 4 pi epsilon naught R. What is this called? I will tell you later on. This is, later on we call it potential at B. This is called as potential at A. And this is called as the work done per unit charge. See the formula. And we got a very, very important formula. What is this? Work done per unit charge gives the potential difference between two points in the electric field. So I am writing it again here. What have we got? We got a very important formula. What is the formula? Work done from A to B per unit test charge. जिस charge को लेके आ रहे हैं उसको divide करें. Now this is it. If you want to generalize it, so this charge can be any charge. 1 coulomb, 2 coulomb, 3 coulomb, whatever you want to take, you can take it. But here in this derivation, we are bringing a test charge Q naught. The WAB upon Q naught, which will be equals to VB minus VA. What is VB? Potential of point B minus potential of point A. So this is the work done by which force? This is the work done by an external force, and this is VB minus VA. Usually we used to write final minus initial. So which is the initial point here? It is A. What is the final point here? It is B. What is VB? The potential at point B. What is VA? The potential at point A. The VB minus VA give rise to this thing. It means यहाँ से लग रहा है आपको कि potential जो B का है वो ज़्यादा होना चाहिए as compared to potential of A. But yeah, we will prove it later on. But at present, see what we have got. What conclusion we have got from this derivation. The work done per unit test charge give rise to the potential difference between 2 points. And this is the electric potential difference between 2 points. इसमें हमें एक चार्ज को एक पॉइंट से दूसरे पॉइंट पर लेके जाना है without acceleration and against electrostatic force. And you can take it along any path. It is independent of the nature of the path followed. This is the formula. Now let's come to the electric potential at a point. Now एक particular point पे निकालना चाहते हैं. ये तो हमने निकाला इस और इस point के बीच का potential difference. This gives rise to a potential difference VB minus VA. इन दोनों points के बीच का potential difference. Now अगर if you want to find the potential at a point, तो obviously we have to take one point at infinity. So I'm making a diagram here. मैं इसको यहाँ भी कर सकता हूँ, but you can compare it. So that's why I'm making a diagram here. For example, this is a charge cube. इसके आसपास क्या होती है? Spherical symmetry क्या होती है? Electric field होती है. Everyone knows it. Previous topics में हमने पढ़ा है. I'm taking a straight path. कहाँ से ला रहे हैं आप चार्ज को? From infinity. किस पॉइंट पे लेके आ रहे हैं? For example, you are bringing it at a point B. फिलहाल at say it is at B. So where is the point A? A point goes to infinity. It tends to infinity. Now where the charge? From where we are bringing the charge? We are bringing the charge from infinity along this path. From where? From infinity along the straight path at P. So what will be the potential? The electric potential at a point in the electric field is defined as the work done in moving a unit positive test charge from infinity. See, from infinity to that point. See, again, against the electrostatic force of the field, without acceleration and irrespective of the path followed. बस इसमें ये है डिफरेंस कि इसमें एक पॉइंट से दूसरे पॉइंट की तरफ लेके आते हैं, ए से बी की तरफ लेके आते हैं. इसमें क्या है? To find the potential at point B, we will bring a test charge from infinity to point B. So let's do it. इसी derivation में, if I am rubbing it here, so before I rub it, just see it here. This is a master formula. This gives the potential difference between 2 points. इसे आप याद कर लें, this expression, and this is very useful, and we got this thing from this. और इसकी help से we'll derive this thing. You can derive it independently also, but using this derivation, जैसे मैंने आपको ये derivation करवाई है, आप उसको एक independently आप खुद भी solve कर सकते हैं. सिर्फ करना क्या है? यहाँ आपने infinity put करना है, यहाँ आपने b put करना है. यहाँ तो I am doing it here. See here. So what we know that? We know that we have derived it earlier. Work done from A to B by moving a unit test charge Q naught is equals to minus the electric field E dot dl from A to B is equals to Q upon 4 pi epsilon naught 1 upon RB minus 1 upon R. अब क्या हो रहा है उस केस में? क्या हो रहा है? The point A tends to infinity. तो point A काफी दूर है, infinity पे है, और अगर infinity पे है तो we know that कि potential क्या होगा. इसका मतलब RA भी क्या होगा? Infinite होगा. Position vector of infinite point. It should be infinite. So put all these things here. So see here, work done. What is the point A? From infinity to B. The work done bringing a test charge from infinity to B. See, infinity to B. किसको लेके आ रहे हैं? टेस्ट चार्ज Q नॉट को लेके आ रहे हैं. माइनस, ठीक है, इलेक्ट्रिक फील्ड वही है, dl कहां से लेके आ रहे हैं? इन्फिनिटी से लेके आ रहे हैं. किस पॉइंट पे लेके आ रहे हैं? B पॉइंट पे लेके आ रहे हैं. Q अपॉन 4 पाई एप्सिलॉन नॉट 1 अपॉन RB. किस पॉइंट पे लेके आ रहे हैं? फाइनल पॉइंट B है. इनिशियल पॉइंट क्या था? इन्फिनिटी. तो put it infinity है. And what do you got? You will get 1 upon RB. What is 1 upon infinity? It is 0. So what is the expression here? It's Q upon 4 pi epsilon naught RB. And what is this? This is work done in bringing a test charge from infinity to B. This is the formula. See here. Abbreviations speaks itself. खुद ही बताते हैं क्या है? What does it mean? It means work done in bringing this test charge from infinity to point B, which is equals to the charge Q, which is this charge. This is the source charge Q. 4 pi epsilon naught R. What is RB? RB is this thing. This is the position vector RB. What is RA? RA is infinite here. RA is infinite. So if you drop the subscripts, अगर आप इन सभी subscripts को छोड़ दें, what do you get? You get a very simple formula. What is the formula? Work done divided by the charge equals to Q upon 4 pi epsilon naught R. and this is called the potential. This is the potential. This is called the potential at point B, or you can say any point which is at a distance r from the source charge Q. So now why this is called potential, I will explain later on. What is the definition of potential? Work done per unit charge is called the potential. So what do we got? Electric potential at a point. What is electric potential at a point? It is the amount of work done in moving a test charge from infinity to that particular point against the electrostatic force without acceleration and along any path. So you got a very important formula today. What is the formula? The formula for potential. What is the formula for potential? V equals to Q upon 4 pi epsilon naught R, which is further equals to work done upon the test charge. इसको हमने सीधा करके लिख दिया. So this is the final, you can say, the formula for potential. So we have derived earlier this thing. We have derived two important formulas. So see once again, electric potential at a point, it is the amount of work done in moving a test charge from one point to another. At a point, it is from infinity to that point. इसमें a point को कहाँ ले गए हम? Infinity पे. R को क्या लिख दिया? Infinity. 1 over infinity क्या होता है? 0. We got this expression. This is work done in moving a test charge from infinity to point B. This is a test charge. This is this. And dropping the subscripts, we get this. We get this. तो हमने आज क्या derive किया? Earlier we have derived these things. आज हमने क्या derive किया? पहले हमने derive किया potential difference, जिसको हम कहते हैं WAB upon Q naught is equals to VB minus VA. ये हमने derive किया. दूसरा हमने क्या derive किया? ये potential difference है. This is called potential difference. फिर हमने derive किया W upon Q naught, which is further equals to V, or you can say this is equals to Q upon 4 pi epsilon naught R. ये दोनों हमने derive किया. This is potential at a point. This is the potential difference between 2 points in the electric field. Now, what the potential gives? मैं आपको और बताना चाहता हूँ. So let's do something. Let's play with this formula. अगर हम इस formula को देखेंगे, तो what the electric potential means basically. Electric potential means the degree of electrification. कोई body कितनी electrified है? अगर ज़्यादा electrified, it means it is at higher potential. So first of all, the potential gives the degree of electrification. It gives the degree of electrification. दूसरा ये बताता है हमें कि how much it defines the flow of electric charge. It defines the flow of electric charge. हमें बताता है चार्ज कहां से कहां फ्लो करेगा. पहला तो बताता है कि how much it is electrified. Higher is the degree of electrification. It means it is at higher potential. It defines the flow of electric charge, and charge flows from a body at higher potential to a body at lower potential. हमेशा बॉडी चार्ज हमेशा कहां से फ्लो करता है? दो बॉडीज में हायर पोटेंशियल से, अगर ये V1 है और ये V2 है, अगर V1 is greater than V2, अगर हम इसे कनेक्ट कर दें तो चार्ज फ्लोज, पॉजिटिव चार्ज, डेफिनेटली पॉजिटिव चार्ज फ्लोज फ्रॉम अ बॉडी एट हायर पोटेंशियल टू अ बॉडी एट लोअर पोटेंशियल. कब तक फ्लो करता रहता है? जब तक चार्ज दोनों का पोटेंशियल सेम ना हो जाए. Just like a heat flows from a body at higher temperature to a body at lower temperature. Size से कोई लेना नहीं, सिर्फ temperature is the measurement for it. The heat flows from a body at higher temperature to a body at lower temperature. Similarly, a charge, positive charge flows from a body at higher potential to a body at lower potential till the potential becomes equal. This next है earth. Earth is taken as at zero potential. हम अर्थ को हमेशा जीरो पोटेंशियल मान के ही चलते हैं. कभी कभी अर्थ नेगेटिवली चार्ज हो जाती है तो उसके कारण इलेक्ट्रिक लाइटनिंग होती है विच इज यूज्ड टू न्यूट्रलाइज इट. अदरवाइज अर्थ का हमेशा पोटेंशियल हम क्या लेके चलते हैं? जीरो. तो व्हाट इज द पोटेंशियल ऑफ अर्थ? इट इज जीरो. मैंने पहले भी बताया प्रीवियस लेक्चर्स में, अर्थ इज ऑलवेज टू बी टेकन एज एट जीरो पोटेंशियल एंड अर्थ इज अ वेरी गुड कंडक्टर. अगर हम ग्राफ ड्रॉ करें रिगार्डिंग दिस, तो वी आर फाइंडिंग इट द पोटेंशियल इज इनवर्सली प्रोपोर्शनल टू अर्थ. As the distance increases, potential decreases. जैसे से हम इस चार्ज से दूर चलते रहेंगे, पोटेंशियल कम होता जाएगा. पॉजिटिव चार्ज का, इसका मतलब पॉजिटिव चार्ज जैसे से पास रहेंगे हम इसका पोटेंशियल ज्यादा होगा, फिर जैसे दूर चलते रहेंगे तो कम होता जाएगा. इसका मतलब ये हुआ कि इलेक्ट्रिक फील्ड मूव्स फ्रॉम कहां से कहां मूव कर रहे? इलेक्ट्रिक फील्ड यहां से यहां मूव कर रही है. यहां का पोटेंशियल क्या है? ज्यादा, और वहां का क्या है? कम. तो इट मूव्स फ्रॉम हायर पोटेंशियल टू lower potential. Electric field moves from higher potential to low potential. तो इसका पोटेंशियल ज्यादा है और उसका पोटेंशियल कम है. As the distance increases, potential decreases for a positive charge. So for a positive charge, the potential is more here and less here, and electric field moves from higher potential to lower potential. Positive charge also moves from a body at higher potential to lower potential. Now let's come to the units, SI units. The SI units of potential, सभी को मालूम, it's volts. SI units of potential is volts. तो हमने क्या किया? We have derived a very simple formula. Potential is equals to work done upon charge. Don't go for the symbols, just simple formula. Potential, work done, charge. Potential का सिंबल हम V लेते हैं, कैपिटल V, इलेक्ट्रोस्टैटिक पोटेंशियल. इसकी यूनिट्स वोल्ट होती है, वर्क डन की यूनिट्स जूल्स होती है और चार्ज की यूनिट्स कूलम होती है. So this is SI unit. What is SI unit of potential? It is volt, and what volt equals to joules per second. अगर हम CGS में करना चाहते हैं, CGS में, तो that is called, and 1 जूल में कितना होता है? मैं भी बताता हूँ. स्टेप वोल्ट. What is 1 जूल? That is 10 raised to 7 ergs. And 1 coulomb कितना होता है? CGS में it is stat coulomb. That is 3 into 10 raised to 9 stat coulomb. 10 raised to 7, 3 into 10 raised to 9 stat coulomb. And this comes to be, if you go it is 1 upon 300. 1 upon 300 something. What something? Ergs upon stat coulomb. See here, you can derive it. 10 is 1 upon 300 ergs upon stat coulomb. और इसे हम पूरे को क्या कहते हैं? stat volt. It is 1 upon 300 stat volt. इसका मतलब one stat volt is 300 volt. So this is, see here. So what is SI unit of CGS unit of volts? Potential, it is stat volt. So what is CGS unit of potential? CGS unit of potential क्या है? It is 1 stat volt. 1 stat volt किसके बराबर होता है? 300 volt. See here. Check it again. 1 volt, 1 joules per coulomb. This is SI. Joules में एनर्जी की यूनिट है, वर्क डन की यूनिट है. CGS में क्या होता है? joules. 1 joule equals to 10 raised to 7 ergs. 1 coulomb equals to CGS में कितना होता है? 3 into 10 raised to 9 stat coulomb. Ergs and stat coulomb give rise to stat volt, and this is 1 upon 300. It means 1 stat volt equals to 300 volt. This is the comparison between CGS unit and SI unit. This is CGS, this is SI. And इसके अलावा we have electromagnetic unit also. Electromagnetic unit. Electromagnetic unit इसको हम कहते हैं ab volt. Electromagnetic unit को क्या कहते हैं हम? Ab volt. And what is that? मैं अभी सीधा ही कर रहा हूँ. 1 volt is equals to 10 raised to power 8 ab volt. 1 volt is equals to 10 raised to power 8 ab volt. तो आप इसे याद कर लो डायरेक्ट. This is 1 stat volt, 300 volt, and 1 volt equals to 10 raised to power 8 ab volt. These are the units of potential difference or potential. So what we have done, electric potential difference between 2 points. 2 points के बीच में electric potential का मतलब होता है the degree of electrification. कोई कितना potential भी वैसे कहते हैं. You have a potential, yes I have a potential. Potential means the strength, you can say. And charge कहाँ से कहाँ flow करता है? Higher potential से lower potential. We have done electric potential difference between 2 points. We have done electric potential at a point. And some importance of electric potential. We have done units also, and the flow of charge. Charge flows from, positive charge flows from a body at higher potential to a body at lower potential till the potential becomes constant. तो आप फॉर्मूले याद रखने कि मैंने ड्राइव कराए हैं, वर्क डन का प्रीवियस लेक्चर में कराया, और आज मैंने 2 फॉर्मूले बताए आपको. Potential difference between 2 points and a potential at a point. That's all for today. Thank you very much.